Hello, and welcome back to the Electronic Show. Right now, I'm right in the middle of a printing process because, as you probably already know, I'm having way too much fun with a 3D printer I just acquired. I have done so many things today. I have so many things I'm going to tell you on the show today. I haven't gotten chance to log into YouTube yet and change the titles for today, but I'll do that later. I will, however, tell you a bit about what I'm going to do during the show. I'm probably going to continue working on the 3D stuff. I'm going to show you a couple of things, and of course talk to you as usual. So we can discuss various things about various stuff that you have on your mind and what I have on my mind, etc. But I'm going to tell you a lot about what I did today. And this has been a busy day, I can tell you that much. I have done so many things, and I experienced so many things too. So if you're truly interested in electronics in combination with 3D and manufacturing processing, etc., you're going to want to see the show today, because I have gained tons of experience the last few days on how to properly do 3D manufacturing and how to make enclosures and stuff like that, and how to make them correct and fit all kinds of electronics and stuff like that. I've also made a new rack for my 3D printer, because it's totally obvious to me that I should have done this years ago. I should have bought a 3D printer years ago. And now I'm even having plans to buy more sophisticated 3D equipment, maybe even CNC equipment or stuff like that, because I'm having so much fun with this processing that is, I can't even describe the feelings that I have inside of myself right now. Just to sit here with my own products, you know, you saw when I printed Noodles, this character, yesterday. And during this night, I actually printed a much bigger version, almost like a statuette, if you like. But I made it a quick version, so it came with a little bit of bugs on it, because I wanted to check out how big I could make the characters and how much I could do in a short time. There's a little bit of noise in the background here, not a lot, but that's because the printer is still working. It is working on what you perhaps saw in the intro here, and that is that box enclosure thing that I am currently working on. Oops. This one. I am working on a box. I'm gonna tell you exactly. Oh, the printer is just finished with another box. Excellent. And I'm gonna show you exactly what that is, and I'm gonna see if you guys are starting to join the channel right now. It is just 3 minutes past starting time, but maybe you guys have understood that it is exactly 2100 hours Central European time when we start. So hi Tim and hi Peter, my two faithfuls. Welcome back. And I am going to show you a few of those things. It's going to be a really exciting episode today, because I've done so much stuff tonight, and I have experienced so many weird things that I'm going to talk about, so we have plenty of stuff to talk about today. So hi everybody, and welcome to the show. Okay, I'm going to show you Noodles, the new ones I printed during the night. Oh, not here. The close-up cam, please. Thank you. This is the one you saw from me yesterday. This is the one that took 7 hours to print. I have another one that's much bigger that took 5 hours to print only. And I even got the name Noodles and my title in and everything else. But as you can see, there's a few cracks in it, and his fingers are a little bit hurt, and there's a little bit of a hole here. Other than that, it came out pretty well. I have to tell you, you're going to be surprised, because this thing here was printed in only 5 hours, and this is a huge character. And that is the fastest I've ever seen. I put the printer on the absolutely fastest setting you can possibly do. So I'm kind of impressed that that's even possible. But I had some problems, which are pretty familiar in the 3D printing world. And that if you don't glue it properly, if you don't have enough glue or whatever, it will bend a little bit. So that happened, unfortunately, which is kind of sad. But I'm working hard on figuring out how to deal with that. I have been working hard to figure out how to treat 3D printing and how to treat everything that I'm doing here. And everything is just a learning process, such as sizes, how to print correct size, correct filling, correct thickness, correct speed, and I could go on and on and on. But I have learned so many things. I've also found a way to clean the top. This one, the one you have seen that I'm using for printing. I have found a better way to clean it than most YouTubers do. I'm going to talk about that in some other episode, not this time because we have so many things to talk about. And as I told you before, I was going to use the 3D printer mainly to do enclosures and robotic parts and spare parts production. That's actually why I bought it in the first place, for my own hobby, of course, not professionally. But it turns out that this one is more than capable of doing professional stuff, and even at high speeds. I just made an enclosure today for a new gadget I've been working on. And I was working on this gadget today, so I actually made this enclosure in Blender in 2 hours. But it was a lot of measurements in order to make this thing work. You may have noticed there is something shiny on the inside. Well, I have this little issue, and this is one of the reasons I love 3D printing so much. You can look at it if you want to. It's quite beautiful, actually. It is not bent. It's just a fisheye camera that will make it look like it's bent. You can see now it's totally straight, and now it looks more bent, and now it's more totally straight. So it has nothing to do with that. This particular unit isn't bent at all. There's a USB port here, so you can see that. And there's a TFT color screen here, and a small button for the reset button. I'm going to show you what that is all about. This is kind of interesting. When you one of the biggest problems when you prototype, for example, with an Arduino Nano like this is an unshipped computer where you have a USB port, complete computer with memory and everything, just ready to use, to be connected to a screen. You have a whole bunch of screens like this, and you don't have any enclosures. And this is kind of annoying, because this has been a universal problem for me for the longest time. When you go to the store to buy all kinds of enclosures like these, you never get the right kind of enclosure. You always get bulky, weird enclosures that never looks good, that never works for your purpose. You know, you have to cut out and drill into it, and it's going to look homemade no matter what you do. And I hate when it looks homemade. I want everything to look shiny and professional and look like it's been manufactured. Who doesn't want that when you have a hobby? So I don't like these enclosures. I have a lot of them, but I never use them because they're clunky and, let's face it, ugly. Let me show you one of those things that I made. You've probably seen this before, but I'll show you anyway. I have it somewhere else. Gathering dust. Everything in this house sometimes gathers dust. That's why I'm not married. Anyway, this is as close as to anything professional I've ever made. And as you can see, not even that is particularly professional. You see there's holes, drill holes on the side. But this is like a standard enclosure you can buy. And I made this weather station with it. It is the same thing. It's just an Arduino Nano that's inside of it. The same thing here. But I had to use this kind of huge box because that's the only thing I had for this. And that makes this clunky. If you're gonna show this someone at school or anything like that, they're just gonna like, what is that kind of item you have there? It looks like you have an item from when you were born or something like that, and old people, stuff. And that's typical for radio amateurs too. When they show something, it's always big and bulky and homemade, which is charming, of course. I find that charming. But I have standards, and I like when things look really cool and professional. So I made this. I was thinking, can't I come up with something better than this? Instead of having to, find all kinds of boxes in order to put these small things together. This is pretty much complete. This is a TFT color screen, and this is a computer with inputs and output all in one. You don't need a huge enclosure, but there's no real enclosure that actually fits it. You can't buy one that actually fits properly, and you have to drill and do all kinds of stuff to it in order to make it work. So I was working on a design today, which I called the Nano Box, and this is my little invention. This actually worked on the first try that I made, and I've been measuring and measuring for hours and hours. This is kind of like this is kind of exciting because it is industrial design. That's what it's all about. It's kind of like designing a cell phone. I had to use this here in order to be extremely exact, because when you make something like that and you're going to make it work out of the box without adding any screws, anything like that, just make it clickable so it just works out of the box, it takes a lot of experimentation. But believe it or not, I got it right on the first print. The only thing that I missed on was the functions that keep the TFT screen and the Nano in place were actually a little bit off scale. They were like 1 millimeter, they should be 2 millimeter thick or something like that. And believe it or not, this click function I have, that doesn't use any screws or anything like that. You can open it. It's quite beautiful. I'll show you in the inside. I'm quite proud of it, as you can probably tell. Since this isn't everyday stuff like that, just work out of the box. Look how it's a very pretty box. And look, it works perfectly together. As you can see, there's click points. Everything that you need to do is just to click it into place. And as you can see, these were too thin. That's why they can break off very easily. But they are click boxes, just like the design I made here from scratch in Blender. This isn't Blender, of course. This is a printer software that I'm using to do 3D printing, but I can show you my Blender version, NanoPrint version 2. Yeah, I had to make two. That's why I'm printing one right now. And this is the Nano Box that I made. And believe it or not, this one worked right out of the box immediately. Let's see if we have some more people that joined us. I'm going back to the YouTube chat. So yeah, well, it does kind of look like on the inside of a house, because it's very complex stuff to do. This isn't stuff, if you don't know anything about electronics, this is very, or designing. I have been doing 3D for over 20 years, so I do have some experience in designing for 3D. But it has to, you know, fit right out of the box. This is obviously a different size screen. Yeah, it's a little bit different. It's a 1 millimeter difference. So I actually had to modify the next box if I'm going to be using this one. Because if you look here closely, and let me see if I can get up the camera. This is two different screen types. You can see they're placed differently as well. So I had to modify for each production, actually, depending on what kind of TFT screen I get. And you can also see the print size here is smaller by 1 millimeter circa, and therefore these are not going to be compatible. But I have 10 of these, I think, so I'm going to find a way to just print another one, because I have the luxury of being able to print one prototype per box. But as you can see, this is exactly the kind of stuff you get when you open something, and this is small and really handy. It is just as small as you expect a gadget like this to be. But I've been printing a new one right now, and let's check that out. Unfortunately, it is quite difficult to make these perfectly level as I managed to do here. Surprisingly enough, the whole entire enclosure here was just printed in 1 hour. In 1 hour! Just imagine the luxury of being able to make something like this with all the internal details and everything else in just 1 hour. What a world we live in. Seriously. It's amazing. It took me 2 hours to design the thing. I mean, the printer was faster than I was. But yeah, I just printed another one. Let's take it out of the printer. As you can see, there's another closure. And as you probably can see, I have improved the size of the connectors to them. And I have to pry it open a little bit, so now you get an insight in that process. I'm going to go to close-up cam so you can see what I'm doing. The stuff you see around here is the glue that I'm constantly putting on. And as you can see, I was a little bit unfortunate with the glue. GNU. I didn't manage to get all the areas, and therefore I have had some rising issues with this. It doesn't mean that this box can't be used, but it's not going to look as professional looking as the first one did. That looks absolutely beautiful. But wait, it's a work in progress, you know. It's a learning process. This one too, this is a button I tried to make the first time. I tried to make it a smart function. That means that the button is using the flexibility of the PLA material. Unfortunately, the PLA material isn't very flexible, but there is other materials one can buy that should be compensating for that. This printer is not really capable of using those, but it is possible to make a so-called modification that makes it possible to use this. I'm going to try this out. There's one good thing about misprint like that, and it makes it easier to take off like that. It didn't come out too bad, but it is a little bit, you know, bendy, as you can see there, and it's not going to look quite as professional as I want it. The button seems to work exactly like I wanted it to work. That's kind of a surprise. That's a nice one. And let's take another cover out here. But the surface looks very clean in comparison to before. That's because I cleaned this one, and that is possibly why it became so bent as it did, because it didn't connect well enough to this. But if I'm not entirely wrong, this one still should be able to. Yeah, it works like a perfect enclosure as well. So it's perfectly reproducible results. But let's see if this thing works as it should this time. Yeah, it works almost a little bit too good. Oh, shit, I broke something. Yep, I was too quick. I have to say, though, I did use the fast mode, the fast print mode, in order to get this one printed. And that's because I'm training how to do that. It takes only 48 minutes to make this enclosure in fast print. That is both economical, it uses very little material, and it prints, instead of 3 or 4 hours, it prints in just 1 hour. And when you're making square enclosures like this with just a little bit of technical details on the inside, that really shouldn't matter. One thing I've noticed though this time is that the name that I put in has disappeared. I wonder what's up with that. Just check that out. The name is gone. This is the first one I made for comparison. And as you can see, I had my name, Nanobox, and plus my name and stuff like that. And that's for some reason gone. This is another one of those surprise bugs that can happen sometimes. As you can see here, it's still in here, so it should be here. When I printed it, it exported just the Nanobox name, as you can see. My name didn't come with it, which is a surprise. But what's an even bigger surprise is that it didn't even come out here. It came out in the print, but not in the actual print. That is a bug, and that's worth looking into. Alright, let's see if this display that I actually made this one thing for will actually fit like it should, because that's always a surprise. I have made a little bit of changes, and it wasn't this. Wait a second. I made a few changes to it. Let's see. Yep, it should be able to fit right in here. I have made these so much thicker now that it may not be. Oh, it works. It glides in exactly like it should. Okay. Right. Oh, it fits perfectly even. Wow. I just have to squeeze it down there somehow. The corner there doesn't seem to fit entirely. That could be a little bit of a printing error, but I can probably squeeze it down there a little bit if I work on it. It is a pretty solid material. I have a smaller section here. Maybe I can use that instead. Man, that really got stuck in there. And that is, of course, the point. I wanted to get really stuck in there. But I have to be really careful with the TFT screens, because they can break quite easily. I have had quite a few break on me in the mail. Could, of course, be the fact that sometimes we have to clean these things. Sometimes we need to clean these things up a little, you know. Especially since I didn't use the fine mode. I just used the quick and dirty mode in order to get this done. as fast as possible. Yeah, there's a little bit of residue I need to get rid of in order to do this. In the future, I can probably guarantee myself against that by actually counting on the actual errors of these things. So I know that these things can happen. Oh yeah, the thing that actually broke off, I understand what happened here. It's supposed to be much more solid than that, but there were a printing error here in this particular area. It's supposed to be one here, but it doesn't matter. I have made so many contact points here that this really shouldn't matter at all. So no biggie. So let's see if I can manage to squeeze this one in right now. Oh yeah, that's the wrong way. That shouldn't be a problem, but it is. Okay, note to self, next time 1.5 millimeter, maybe. Not on these are actually perfect, but on the other one maybe, that should be, it squeezes in now. Okay, that's a perfect fit. And this is why I'm doing this. I'm doing this so I never ever have to use screws. Because that's exactly what I want to achieve with this thing. I want this to be impossible to get loose unless you want it to get loose. But I want it to be super, oh, where's the camera here? Super solid, as you can see here. Now you can't even get it out that way. It's supposed to be exactly like that. It's supposed to be an industrial project after all. And it seems like the spring button is actually working this time exactly like it should. You can see it bends a little bit here. And I made that as an industrial design and a trick in a way. So I don't have to print another button and then put it in manually and stuff like that. I made... Oh yeah, there's a support here I need to get rid of. These supports are often placed by the software itself in order to be able to print the overlay here, as you can see. I made the hole a little bit bigger, so hopefully it will fit straight out of the box this time. Because last time I had to file down a little bit. But yeah, it works straight out of the box this time. It fits directly into it, actually. No problem at all. It's so solid I can't even move it. Yeah, everything is solid. This thing not gonna fall apart, as you can see here. Both PCB are perfectly in place. The nano box works exactly like it should. It has a USB plug now, which means it can be used for development, which means no longer you will have to have separate things laying around or find the right box. It's just to buy those right from China and plug it right in. This nano board costs $2 and this screen costs $2.50, a color screen. So this is probably as cheap as development ever will get. So let's see if this works after all. It doesn't matter if it's a little bit misprinted that way. It doesn't really matter. It works perfectly well anyway. And my goodness, I love when things just work out. Listen to this. Can you hear the clicking sound? That is the sound of success. That means that my 3D printed design button actually works right out of the box. There is a small button behind here, which you could see in the other model right here. If I place this one back, here, yeah, it still works sort of. But if you see what I mean, there is a small button here behind it. There you can see it. That's the button I made a button for, because I wanted this to, every time I print a box like this, just to have the reset button available. But you can hear the clicking sound, and that works perfectly fine. So that's pretty awesome. Simple little box, just printed. As you can see, the corners didn't come out perfect, but you can still assemble the box just like a real device. And the first one came out much better when it comes to printing, but that's because I got it to lay I did glue the whole entire area, so I got it to lay on the table, the bed properly. As you, they are exactly the same, but this one has a little bit of a printing bug here, since yeah, it's skewed a little bit. You know, it's melted together a little bit, but it doesn't make any difference in the function. It works as it should anyway. So yeah, that's pretty sweet. See what you guys say. Hi Benjamin, and welcome to the show. Yeah, you can glue PLA. You can even wash it, it turns out. So it's actually pretty cool. Yep. Well, you can of course fit anything in there. I was planning on actually making this a Wi-Fi finder, if you like. So that was actually one of the plans that I had. That's why that's actually why I came up with this design here. Yes, you can definitely glue a couple of pieces together. That's no problem. But it's better to just do that with a heat gun or something like that, because this melts. This stuff melts in heat. That's why you don't want to show this. You don't want to have this laying in a hot car, because I'm not kidding you. That thing is going to be melted. Because yeah, they have a weakness when it comes to melting. That's why they melt at such a low point anyway. But yeah, this made prototyping ridiculously easy. I mean, this made me think I am going to do this for the rest of my life. I'm probably going to buy more printers that can take ABS and all these other special materials and stuff like that, because I'm totally hooked. This is the thing for me. I mean, if I can make this stuff on the first freaking try that I did every single time in 3D software, just like I did here, just by simple measurements. I was just measuring the stuff I was going to make a box for, and it just worked out straight out of the box, and just directly out from the printer. I mean, how cool is that? Just manufacturing things. I mean, there was times when I was thinking, I was watching all of these YouTube videos, and there's so many people making, you know, Warhammer characters, but they have so many issues. You can see them work for hours and hours with stuff falling apart, with stuff that doesn't glue properly together, and misprints and stuck heads and stuck this and that. But it turns out you just need to work at it. If you do, you're gonna get pretty good results. And you guys who are already interested in technology, this is whom this is made for. This is not yet made for the average Joe who is afraid of repairing things themselves. They're never gonna figure this out. I mean, they're gonna be able to use a printer like this, but they're gonna be able to return it just after a couple of weeks. And I can tell you, my printer clogged up for the first time today. It had 17 hours of use, and it clogged up. And the usual manual that came with the Flashforge is crap. Pardon me my French. It is really bad. It does not explain to you how to fix a clogged head, and I googled frantically. I went to all kinds of forums, and I thought my new fancy, relatively cheap 3D printer is gone. Now I'm probably going to have to send it back for repairs, and I googled forums, and people have sent stuff like that back for repairs, but they've gotten really good service from that company, by the way. I got to say that, because I didn't see anybody having problems with it that way. But they had new nozzles and new heads and stuff like that, or new PCBs sent to them, and I don't want that. I have an electronics workshop, for frick's sake. I mean, I can build and fix things myself. But I found this video on the internet, however, with a guy who doesn't really speak much, but he showed how to unclog it, and it was really easy actually to do it. All it took was a lot of fiddling around with the head itself, and jog up the temperature. You can go manually into the Flash software, and you can jog up the temperature, and then the rest of the stuff just melts out, and you can push the new stuff in. So that worked out somehow. So that's pretty great. I'm quite happy about that. So it was a learning process today. Another thing that you probably have noticed is that I have a gray box today instead of the usual white stuff. I have a gray now this time. So did I change Did I change the PLA? Yes, of course I did. And I did something extra interesting as well. But before I show you that, I'll go to you guys and see if you have any questions. Alright, not really. Okay, let's go and I'll show you what I did. It's better that I just show you what I did rather than explain it. I built a rack for all the PLA that I got and for future PLA rolls. Because using the built-in feeder and stuff like that, that means I have to change it all the time, take it out, the sensor, take it back again. And it's just annoying. And I know now for a fact that I'm going to be using this stuff all the time. Seriously. So, yeah, let me show you. I just adjust the camera so you can see what I've done. Yep. Let's see if I can see it properly myself. Ah, yeah, you can see it. Okay. What I've done here is kind of obvious. I have made a roll system for it. That means I can just change whatever color I want to, and is relatively solid as well. And I'll show you why it is solid and why I have worked so hard to get it properly and do a good job with it. I'll show you why. If it is possible to have a, unfortunately I don't think my camera reaches that far, but I'll see if I can turn this thing around because I've connected it to the printer itself, so you get an idea of how it works. Hopefully you guys can see this. But what I've done here is that I have made a click-on system, so this thing doesn't fall over. As you can see, it already have legs that it can stand on. If you can't see that, I'm going to adjust the camera a little bit so you can see the legs. You can see it has legs connected to it and everything else. But I've done something else as well. I have made a click-on system because there already are screw holes everywhere, you know, where the printer itself is assembled. So what I've done is that I have made a click system, as you can see here with these little knobs here, which means I can just click these in place like that. Click, it says, and now it is solidly wedged as a part of the printer, so it doesn't fall back or anything like that. I also had to use a really solid steel rod instead of using the plastic one I made first. Earlier today I just used a PVC pipe, but it turns out that these things are so heavy that in fact they're so heavy that they will bend this thing. You see, this one is actually quite hard, but believe it or not, with these 3 PLA rolls, it was actually bending like that. Even if I had to press hard like this, it's several kilos, and it's actually quite heavy. So, and that means that these will fall together and start spinning on each other, so that's a bad idea. So I had to use I just use an IKEA steel rod, the same rod that you can use with curtains from IKEA, etc. Stuff like this. Very simple stuff, basically. And yeah, that's pretty much all she wrote, I guess. Alrighty. Let's see if we can adjust the camera a little bit. In the future, I'll probably make a robotic tilt and pan function and stuff like that too, which we were talking about earlier, especially you, Benjamin. We were talking about this Tinsy, using a Tinsy for that. I don't care about a Tinsy. I'm probably just going to use an Arduino. I don't care, but you can probably use that if that's what you want to. So it should be working just fine. So yeah, you betcha I've been busy lately. Let's see if you have anything to say. Right. Thank you. Right. Yes. So that was pretty much it. So I've been busy, very busy, but I really like this design here because it makes it very easy to work with things. I'm gonna do something like that for the OLED screen that I've got as well. I'm gonna make a modular system as well that makes it very easy to design for these things. But I really like that everything worked out of the box like this, so you can see this is not gonna fall apart by itself. And as you can see here, this is super solidly wedged in here. And you can't tell that this has been made by a home brew kind of guy. And that's exactly why I want it to be like this. So you can toss it around like that. It'll be able to stick in place. It's not going to be problematic with any kind of prototyping whatsoever. It is going to work out of the box all the time anyway. And that's exactly the way I want it to work. And I've designed this so it clicks into place very simply, like that. And you can only peel it apart, just like a cell phone battery in a way. Because if you see, if I'm tossing this thing around like here, this will not split or come apart at all. It will be quite solid together, all together. I have seen an Arduino being used as a head, so it's quite possible, but you have to have a special version of an Arduino. I think they call that the Nano Pro, if I'm not entirely mistaken. I have one of those. Let's see if I have it somewhere. Do I have that somewhere here? Or is it the Nano Micro Mini? It might be the Nano Mini, I'm not really sure. But this one is supposed to be able to use as a head device. This one comes with the extra needed for that. It doesn't come with a USB to serial, you know, but it has something else that can be used for that. I also have some other ARM Cortex versions, some miniature versions, stuff like that. It's a super small and cute and cost only I didn't even pay $2 for it. I think I paid $1.50 or just $1 or something like that for them. I've also bought some bigger Arduinos, if you like. These are not your regular Arduino. This is a really flimsy version, by the way. I'm going to show you close up much better to do that. I never got this one to work. This is an ARM Cortex M3 processor, and this is supposed to be a Maple clone, but it didn't work. And since I bought a new type of Maple clone, this is an ARM Cortex M3 as well, 32 megabit processor, 80 megahertz speed, so it's pretty powerful. And it costs like $4, twice as much as the Arduino cost as a clone. This is also a clone, but the Maple is no longer in production, but you can still get clones like this on eBay. This one actually works. I just have absolutely no idea how to program it yet, but I'm gonna figure that out someday when I actually need that kind of speed and power. For now, my little 16 megahertz Arduino has been doing just fine. I haven't had any needs over that yet. I've still yet to use all the capacity that it has, so no worries in that department. And yep. A box, will it blend? Well, you know, it isn't any. I kind of resent that. It's not just any kind of box. This is a box that I've been thinking a lot through. It fits. You have to understand the design behind this stuff. This is not easy stuff for your average persons. I mean, if you think about this, let me show you a little detail here on all the things you have to think about when you create something like this. This is actually a little challenge if you want to know. First of all, you have several stages here you need to take care of. You have this stage. This is the thickness here. Maybe it's 2.5 or 2.3 millimeters. You also have the PCB, which is 1.5 millimeters. And if you want the clip-ons, you have to make sure that the total height, including the space in between, is perfect. And you also need to make sure that you have the distance from here to here correctly. And you also want to make sure that you have 2 to 3 millimeters spacing, so you can only see the screen itself when you do this. Otherwise you'll be able to see the white stuff around and you'll be able to expose the electronics. And as you can see, there's a driver chip here which you also need to hide, and that's like 1.3 centimeters right here. That's 13 millimeters. You need to design that too, and you need to make sure that the clips go correctly in. And I was thinking about how can I make this as small as possible, because I wanted to make sure that I can use as much space as possible, as a little space as possible, and make it just click into place like it does here. You have to know exactly how wide this is. You know to know the exact position of where the micro USB goes, so everything fits perfectly in place. This is a distance you need to know. This is a distance you need to know. You need to know the height. You need to know the difference between the height of this board and the height of that board in order to make those overlap. You need to know the exact position of the reset button. So if you want to make an all-in-one button that has a spring system just made out of PLA instead of having to insert a component like that, then that's something you need to know as well, you know. All of those things are you have to think about. So and that's not all. How did I make this fit perfectly? You think it's as simple as just asking the computer to separate two objects? This isn't Solid Brush. This is Blender. It's a visual 3D tool. You need to measure everything yourself by hand, because Blender only measures in units. And units are the same no matter what. There's no millimeters, there's no centimeters. There are only these little things here. I'll show you what I mean by that. There's only this grid net, and I had to sit here, and I'm not kidding when I'm saying I had to sit here and count every single little detail. I'll show you what I mean as how I did that. To me, I have decided that this is a millimeter scale. So when I worked with this, every single one of here is a millimeter, and the screen is also a this is a half a millimeter, and I have to count every single square in order to make it perfectly match all the different measurements. The same thing goes for all these things, how it clicks, how high everything is, and how this clicks in perfectly into place without interfering with any of the components, etc., etc. You try to do that in 2 hours and see if you can call it a box. But okay, yep, that's the way that is. Any questions? Well, it's not really like pixels. It is you decide what a unit is. Just as the most important thing that you do is that you think about units as proportions. You know, it doesn't matter if a centimeter is a centimeter. It doesn't matter if it's 10 centimeter, a decimeter. It doesn't matter if it's a meter times a meter. You know. A unit is just a unit. You just have to make sure that the proportion is 1-to-1 and perfectly clear. So what I did, I was making a measurement for this, and I measured the screen and the size of the screen, and I measured the entire box that I wanted to have, fictional if you like, by counting the size of the screen and adding to the screen, the side of the screen, so to speak, as added proportions here in millimeter. And then when I was done with that, I knew exactly how big this thing was going to be in order to match the proportions of the screen and this nano. So what I did was I just entered the size in the printer, this printer software here. Because when you right click on it, you go to scale, you can input the exact size. So then you can match it with Blender. So it's not really that hard. But the absolutely hardest part, and that is the fidgety part, is to know exactly where everything here goes. And when you work with different layers of prints that you have to get to be stuck here. Because the trick here is to make it entirely independent of screws. There's no screws here, there's just click functions, everything. And there's not even a spring for the button. It's just I'm just using the plastic itself as a spring, if you like. And this is probably how I'm going to design all the units in the future. perhaps a little bit rounder and prettier designed, etc., etc. Yep. Yeah, you can scale inside the software. I could scale this one to twice the size, but you can't. The software, the printing software itself, will not allow you to scale just a part of it. You have to scale the whole darn thing. So if I go into this printing software and rescale it, it will scale everything. But of course, in Blender, where I have designed this whole thing, I will of course be able to scale the screen to match. For example, we were talking about this other screen here that maybe is a millimeter smaller. Then I would be simply just going in here. I want to see it through. Then I only would be taking the side of this one. Oh, wait a second, that's not just the screen, it's this as well. Yeah, I had to move the entire click setup, including the corners here. As you can see, I need to move all of those in order to fit the new PCB, because the new PCB has 1 millimeter less on it than the other one. So what I would do is that I would mark all of these vertices here, at least those that are related to screen, maybe the whole thing just for design's sake. I like to keep a clean design. I don't like stuff like you see here, but that was necessary because of some adjustments I have to make. But I like everything to be super clean. So what I do here now, oh wait, that's not good enough. That was just marking some of it. I have made some quite serious design changes. But okay, yeah. And in order to find out what a millimeter is, I have to go in here, and yes, you can, as I told you, I have counted that one of these squares is a millimeter. That's because that's the kind of scale I have selected. So what I have to do is that I need to make this one smaller like this. And then this new design here would fit the new screen or the new PCB. As you can see the difference here, simply as I did here. Yeah. And that's how you do it. No, my friend, you don't make a design like this in 2 hours in Blender. Did we just disconnect or something? Are you still here, guys? Because it told me it just disconnected for some reason. OBS just told me that it was disconnected. Are you guys still here? If not, I have to check this out and see if it works. I'll log into YouTube. Okay, so you guys are still here. That's good. I'm gonna log in and just check and see if everything's alright. Yep, everything is alright. Good. Okay. I'm gonna answer your question. No, this is not my first time at Blender. I have been working with 3D for over 20 years. I have been working with Blender for over 16 years. So no, this wasn't made for the first time in Blender for me. And I have extensive experience in Blender. But it is the first time I do this with a 3D printer. But it isn't the first time I am doing a printing with 3D printer. I just did that yesterday, with Noodles, as you saw. The character I was printing out, this one. This here, this Noodle character. That took 7 hours to print, by the way, because it has high quality print to it. So yeah. Alright. But yeah, there's no doubt this is the future. This is the way to design stuff in the future. Simple electronics, simple screens, and make it much more smaller so it fits a modern life like today. So this is a way better way to make prototypes. It's almost ridiculous how much fun this really is. So there's no doubt that I'm going to be doing a lot of this in the future. Especially since this just take 1 hour to print the whole entire thing with the interior and everything. Just imagine if you can actually technically print anything. If you can print a fully functional button like this, then you can print anything you want to. You can make you can actually print an entire functional clock. You can just make a bunch of cogwheels if you know how to design it and time it correctly, of course. And knowledge. You can't run away from knowledge. You need that anyway. But you can technically make a robot with gearing systems. That's another thing I've been thinking about, making my own miniature gears, because I have these small pager motors that I've been hoarding for a long time, and I've always been wanting to use those for something really interesting as miniature robots. But people on eBay are usually quite greedy. They know that people are fiddling around with robotics, so they take extreme prices for something like this. They charge like sometimes $10 just for one of these small pager motors. And they do that because they know that hobbyists like to fiddle with these. So they charge an absolutely crazy fortune for it. I found somebody who didn't charge a fortune for it, so I bought a whole lot of it. So I hoarded it for the future. But I'm going to make a small plastic gear for this, so I can make super small nano robots with the size of this, just using this as a brain. Maybe even just using this as a brain, just forgetting everything else of the development board, and make my own development board instead. That would be a lot more fun for the future. Now that I can print anything I want to, any idea I have, I can just print. I mean, where was I when this stuff came out? I mean, seriously, I didn't really believe in it, but now I'm a true believer. I'm going to be doing this for the future and forever. 3D printers like this is going to be my friend for the rest of my life. I'm going to buy more printers like this. I'm probably going to buy one that can use these metals on a roll as well, just to be able to do absolutely everything with printing, because I can clearly see I'm going to be doing this all the time, whatever I do and whatever I prototype, because if you can make a small prototype like this look this good in such a short time, just imagine when you're going to show somebody something that you made, invention or something like that. You have a new idea for a new detector or whatever you want to make. You don't want to come with a clunky thing like this and look what I made. I just found a box and put some components in it like the old geezer. But you can come into this century and actually have it as thin as a cell phone with a TFT screen and everything else. Now you're talking modern production. I'm thinking, just for fun, I would actually like to use this super small module OLED screen I had here, which is just a couple of millimeters wide. And just for fun, I think I'm going to make a credit card sized computer, which I can actually wear inside of my wallet. Just for fun. Maybe even a Wi-Fi detector with a complete computer screen and graphs and everything else shows exactly where they are and how strong the signals are and stuff like that. I have never seen that. I've been Googling that. I've never seen anybody even producing that in a factory. But it can be fun just because we have 3D printers. As long as we have the imagination and stuff like that, we can just do things like that. Just I can't even imagine not more people are doing this, because when I Google 3D printing and when I Google enclosures, this is just a standard word, enclosure. 3D print your enclosure. There's maybe 10 videos that you can find on YouTube that actually shows you the printing of enclosures. So that just goes to show that most people don't have a clue. They all print just standard, I made these characters here, but most people, they don't go through the rigorous process of making and designing a character like that. Most of them just download them and purchase them from TurboSquid or Makerverse or Maker Thingiverse, I think they call it, where you can download thousands of different already made characters. They don't make them themselves like I do. And but it shocks me to see how few people actually do this. Ben Heck is one of those people who actually does this by himself. I remember when he started humbly by using, he designs his own molds, and he got somebody to print it for him, and then he finally got a CNC machine himself and CNC'd everything, and he made these portable video arcade machines. You know, if you know Ben Heck, you should watch his show. It's called the Ben Heck Show. It is absolutely amazing. This guy is absolutely fantastic. He has learned everything from scratch, basically, and he has like 2 or 3 3D printers in his shop. You can see that if you watch his videos. And now I understand why he has so many 3D printers, because you know he can just build anything he wants to from scratch. But there's like, I think there was like 1.1 million sold 3D printers. What are people making with these things? I mean, 1.1 million 3D printers sold, and all I could find was 10 videos of people making enclosures for gadgets and new inventions. They're either hiding their invention and not showing it on YouTube, or people are not just they're just not capable of doing it. But let's face it, everybody can press print. You can. It is true that if you buy a 3D printer like this, you can be a 12-year-old kid, and you can download an app, and you can download a couple of characters from Thingiverse. Just insert the PLA and press print. And a few hours later, you have one of your favorite Digimon or Pokemon characters or whatever you want to do. But to make stuff yourself is much more than that. You need a lot more than that. Yeah. Sure. And I would love a Back to the Future car, DeLorean DMC-12 myself. I would love that. But I'm probably not going to sit here for hours and hours and hours and then make one step-by-step video about that. But I will, however, give a few tips and hints on how to connect certain things and how to get things up and going, and what kind of pitfalls you have to look out for in order to do these things. So definitely, yeah. So Peter, you have bought some printed stuff from Shapeways, enclosures for GoPro and things for drone. Ah, yeah, that's okay. A lot of people are buying things from Shapeway. Speaking of which, I actually checked out what it cost to buy stuff from Shapeway. That if you wanted to print yourself, your own stuff. I found out this character here, this exact size actually, which I printed out myself, would cost me $45 to print out from Shapeway, including the $15 shipping it cost to ship this thing. And there would be a lot more prep work for me because they have all kinds of specifications that need to be met in order to be able to ship it or upload it to Shapeways. The good thing with not doing that and doing it myself is I don't have to do all of that prep work that they are asking for. I can just do my own prep work that fits the need that I have. And when you think about the price of PLA, which is basically just $15 for 600 grams, that's 250 meters, I could print 11 of these, and I've already paid for the printer. That's actually good economy. 11 of these, and I've actually paid for the whole entire printer. So it pays for itself really quickly. But of course, Shapeway is the way to go if you don't have that opportunity or that luxury, or you don't know how to do that yourself. But I can definitely, if you were technically inclined and you're watching this show, I will say go for it. Try to do these things yourself, because you're going to have a lot of fun. But don't expect it to be a smooth sailing, because there will be tons of stuff you need to be learning, such as the clogged printer head, as I was talking about. All these things, you can't just go and claim warranty. You have to fix these things yourself, because they are still DIY. Everything that you do here, and everything that we do here is DIY, do it yourself. So you can't just go claim warranty. You have to fix things yourself, and you got to Google stuff, and you got to work with things. You got to be active when you're doing these things. That is exactly what I'm thinking, Benjamin, and you can probably pick one up for a dime a dozen. I mean, seriously. I have been Googling, before I actually bought this 3D printer brand new, I have been Googling something called Blocket in Sweden, And there were tons of 3D printers for sale. Let's see how many 3D printers there are right now. This is right before Christmas time, so it's probably not the best time to do this. But let's check it out anyway. Let's just check out. This is the Swedish version. There's a lot more in Denmark, by the way. I checked that out as well, just to see if people have them for sale. I'm going to go where I usually look for used stuff, which is called Blocket in Sweden. And let's find out. Oh, this looks like a mess. Let's fix that. Better. 3D printer. Sometimes they call it 3D-skrivare in Swedish. Let's go for the whole entire Sweden and see what we can find. And yeah, there's a bunch of people trying to sell their printers. Here's a guy selling a Flashforge Dreamer. That's the bigger version of the printer that I have. He wants 9,000 for it. That's roughly what you can buy it for if you buy it abroad. But I think it costs like 12,000 in Swedish, and he's wanting 9,000 for it. But you can see he listed this 9th of November, and we are in December now, 7th of December, and he hasn't been able to sell this in Sweden, in Malmö, which is a big city of 300,000 people. He hasn't been able to sell this for almost a month. So I'm betting people don't want to. And there's another guy who listed 16 October. He's trying to sell a Maya dual head for only 6,000. Wow, that is really cheap, by the way. It has two heads, which actually means you can print with two colors at the same time, or make it easier to dissolve if you use one dissolvable material and another one with a color instead. Maybe I should give him a bid on that one, because most of these people, they sell this because they have no clue, and I'm not kidding. If you Google people who are using this on YouTube, if you go to YouTube, and I am surprised because I have been so interested in 3D printers for so long that I was actually convinced by all the YouTubers how much trouble and how many problems they have. But you shouldn't really underestimate the lack of knowledge and how scared people are of problems. People are afraid of problems. I'm not kidding you. I've been looking into the forums where people have been buying things. I bought one of these for my son, and just 2 days later it broke down and it didn't work, and I wanted my money back, but nobody helped me. Anybody want to buy a cheap 3D printer? You know, and there are so many of those. All you really have to do is that you got to DIY things a little bit yourself. You got to open them up. You got to get your hands dirty. You got to try. You got to be willing to experiment and stuff like that. Because these big, nice commercial models, they don't break down just like that. They don't crash and all of a sudden the stepper motors burn and stuff like that. These are big commercial models. They've been researched for like 5 to 10 years before they even hit the market. So they're not that bad. But people are, maybe, I want to be positive. I want to say that 3D printing is for everybody. But don't kid yourself. I make it look easy because I've been doing 3D for 20 years. I've been doing 3D modeling for 20 years. I know what pitfalls to look for when I'm printing something like that. Even though I never owned a 3D printer before, I know how to make a clean 3D model without double faces, without double vertices, with the right proportions, with the right kind of thickness. Tons of stuff that normal everyday people just wouldn't think about because they've never worked with it. So, but you need, if you're not afraid of experimenting, if you're not afraid of using a couple of rolls, if you're not afraid of a little bit of clogging here and there and cleaning up and learning, and a steep learning process, then 3D printing really is for everybody. It's just like any other really cool hobbies. For example, it's not easy to fix or repair cars either, but yet a lot of people do it because they can. For example, in Osby, where I live, there's like tons of people who like to mess around with cars. After all, we have USA cars just nearby here, and people like to even build and modify cars. I couldn't repair a car. I couldn't repair a car if my life depended on it. That's because I'm not really a grease monkey. Sorry about that expression, but I always call them grease monkeys, you know. I don't like the oil, and I don't like the to mess around with big parts. You need to have really big beefy muscles to move around. 3D printing, this is up, you know, with electronics. This is soft stuff for me, that I use this one, but not so much these. And I like that better. So that's my preferences. But that doesn't mean that one thing is worse or less than the other. It only means we can't be jack of all trades. I mean, I am pretty good at 3D, but I suck at fixing cars. My neighbor is an expert in fixing cars, but he couldn't fix or his computer to save his life. But I would gladly help him any day when it comes to that. He doesn't live here, by the way, anymore. I'm referring to an earlier neighbor, so that's why I'm saying that. So just in case you're watching, Pierre, yeah, that's you. But anyway, that's the way it is in life. We can't know everything. All right, your video has been quitting on your Apple TV 5 to 6 times. All right, that's sad because it only quit for me once, so it could be the internet connection or something with YouTube, because it only quit once for me anyway, and it showed me that because Open Broadcast Studio showed me that it lost connection with YouTube and is attempting to reconnect and then reconnected. It only did that once. But maybe YouTube has an issue or something like that, because it's been working perfectly for 7 days in a row. So of course it can happen. Yep. And there you go, Benjamin. You can maybe pick one up cheap in your place, and if you, I would actually recommend doing that. Just stay away from the absolutely cheapest model like the iPrusa i3 or Prusa RepRap and stuff like that, where basically people build their own 3D printer. If they can't use the 3D printer properly, if they don't have a proper use for the 3D printer, don't expect them to be able to build the 3D printer, if you know what I mean. Because so don't buy. You can of course get lucky and you can get one Prusa that you can manage to fix, because I don't know how technical you really are. I know you're a good programmer, but I have no idea how technical you are when it comes to fixing things, electronics and stuff like that, and how handy you are with mechanics and building stuff. That's something you guys know about yourselves. I don't know that. But I do know, if people are buying these Prusas and they're trying to assemble them and they don't get them to work, why not buy an already made 3D printer and start there? Me, I've been working with electronics for over 30 years, yet I am buying a commercial model because I want to start with something that I know, something that's easy to start with, I can understand, instead of just building something I may not even understand how to use. So yeah, but then again, I could be wrong. Yeah, but it is a cheap entry level do-it-yourself. I mean, I've heard you can get one of those i3 Prusas for like $130, and I have heard people who have great success with them. I've even seen some pretty decent prints made with them. But those people have been really technical people, people who are building and constructing things, and they're building their own computers. They are even designing PCBs themselves. These people are competent people. If you are just a fumble finger and you just want to save money because you don't want to pay $500 for a cheap entry printer, you have to think twice what you can expect for $150 or €130 or whatever they sell for. But they're relatively cheap today. They basically, because they are made by printed parts. They print them and resell them as parts, and that's how it works. I wouldn't do that. I wouldn't dare to buy that, especially when, I mean, seriously, you can get this beast here for $500. That is a professionally made commercial huge model with color screen and touch screen and everything else. I wouldn't even bother with one of those Prusa models or whatever. But hey, your mileage might vary. All right, we are 10 minutes over schedule. I'm supposed to be here for 1 hour, but it was so enthusiastic and interesting to talk to you guys about this today. So I got a little bit carried away because I'm really excited about this stuff, you can probably tell. Because, let's face it, I'm going to be making robotics and enclosures and models like that all the freaking time. This stuff was made for me. I'm not ashamed to say that. This stuff was made for me. I'm just a little bit miffed that I didn't do this years ago. I should have done this. I should have been one of those people who were jumping on the MakerBot wagon like 5 years ago when the MakerBot was actually making their first model, because a lot of people had a lot of fun with that, but thousands and millions of people didn't, even though it was sold over 1 million, not the MakerBot itself, but total sales of 3D printers, because you don't see a lot of them actually. It didn't become the big hit everybody was thinking it would become, but I personally believe that's because it's still a little bit hard for your average Joe to figure out all of these things. You have to be technical, you have to be able to design industrial products, you have to be able to model things, you got to be able to fault find, you got to be somewhat of a technician, you need to have a little bit of a programmer in you. You need to have all of those things in order to make it successful. Of course, you can buy a printer and just download a model and press print. But you are going to get problems eventually. The head will clog. The bed that it's sitting on will glue together. It will get uneven at some point, and you'll have to recalibrate. I recalibrate almost every second print, and I do that in order to avoid getting these bent edges and stuff like that. And you can buy a super expensive model that has automatic leveling. Some of the new Prusas actually have automatic leveling, so you can even do that. I think it's the AI8 or something like that. I think that one has automatic leveling, but they will improve on these things eventually. But still, you're not going to get away scot-free without trouble. I mean, I am a fairly technical guy, and I had problems after 17 hours. But it still doesn't mean that the whole thing will break down and fall apart. It's just a matter of fault finding and get it up and running as quick as possible again. It is still a relatively new technology, and don't expect it to be some magic stuff where you can just solve all your problems within designs and printing and expect to have a cell phone or a robotic car printed out for you because everybody says that it's the coolest thing is the business, You have to have knowledge in order to use these things, so don't kid yourself. But it is a lot of fun, and I'm going to be playing with it in the future. But as I was saying, we are a little bit over time, and I'm tired because I have been awake since 7 o'clock, actually 6 o'clock this morning. So to me, it's late. I'm probably going to go to bed in about 1 hour or something like that. I'll maybe make one more print before I go to bed. Sit there and see if I can design a different model with different buttons and stuff like that. It's fun for me to do. So that's probably what I'm going to do. Thank you, Peter. Thank you, Tim. And thank you, Benjamin. And thank you, everybody who has been joining. Yeah. You should do that, Benjamin. You should just buy one that just works. But there are no 3D printers on the market that will just work all the time. But yeah, it takes time to master. You have the right attitude, Benjamin. It's true. If you want to go cheap, you can buy the similar model that I bought. I can heartily recommend the Flashforge 3D printer, which is called the Finder. This is the entry model. I would heartily recommend it, but you need to know that you need to have some technical knowledge in order to fix the problems when they arise, and it's just a matter of question of time. If you read all the reviews that everybody has done with all 3D printers, no matter what brand it is, there's just a matter of time before the head will clog, before the bed will level out of position, before you need to realign, etc., etc., etc. All of those things are important. So you need to be aware of that. It doesn't matter how expensive your model. You can buy a 40 or 50,000 set systems 3D printer. You'll still have to learn about all of those things. You can't escape it as it is today. But sure, buy a commercial model. Okay, thank you for today, and I'll see you tomorrow. And thank you everybody for watching.